Hello, good morning, and welcome to today's class. I'm happy to have you around again, and thank you for following. If this is your first time of coming across my video, my name is Emmanuel, a JAMB exams coach. I have students I'm preparing for JAMB 2025, and the goal is to have as many of them as possible to come out with a minimum of 250. And if you come across this video uh, and are interested, you can let me know in the comment section. All right, friends, welcome again. My students, this video is very important. I'm going to reveal many things. Please. Now, I've told you in the last class that I have observed that dealing with past questions alone is not sufficient, because in my previous videos I try as much as possible to not just deal with past questions. You have watched them and you've known that as I discuss past questions, I also try to answer several questions around each question I discussed. If you observed carefully, sometimes if I answer one past question, I try to provide answers to several other four questions, four or five, sometimes even more than that, around that particular question. The goal is to prepare you so that any question that comes around that area, you are already prepared to answer it. But then, even with this, I have discovered that it is not sufficient. So, I have since started dealing with JAMB syllables before I now come up with questions you should expect. So, you see what we did in biology. I've already taken the first part of the syllabus in biology, and I have made a video on that. You guys have watched and you have seen your participation, right? Some of you were scoring 27 over 30, 28 over 30, 29 over. In fact, there was no 25 over 30. The minimum was 27. So you guys are doing very well, and I'm so happy. And guess what? Inside that particular topic, I try to ask every possible question Jambo asks. So now tell me, how can you go into exam hall and cannot answer any question that come under that topic that I have treated? Do you understand the point? But if I were to dwell only on past questions, it wouldn't have been like that. You may go into exam hall and see a question that we have not treated. So friends, this is why I came up with this strategy, and it is going to work for us massively, I tell you. So just make sure that you follow carefully and make sure you participate in the assignments I do give. Train yourself, prepare yourself. I've told you in one of the classes that it is one thing to really know something, is another thing to bring it out. This is one of the reasons why we are doing mental drills. I hope you guys know that. So mental drills, in as much as we are after speed and accuracy, I'm also trying to train you on active recall, how to bring back what you have learned in the past. Let me not bring my experience here. I have said it several times to my students. If you are new here, you may not really grasp what I'm talking about much, but you can be part of my students. Just indicate your interest by chatting, "I'm interested in joining this class," in the comment section. I'll find a way to add you later. But what I'm trying to say is that don't even be proud that I know it. If you know it, be able to bring it out. That's when we will know, yes, indeed, you know it. And that's why I engraft these trainings gradually. I don't just answer questions and go like others do. That's the difference. I've already mastered what works. I have tested it on students at various levels, from lower level classes, primary, to the university. Yes, so please and please follow me carefully. In this video, there is something very important I did. I first of all discuss the syllabus, the topic we are going to discuss today. I've explained it. I did my best to make sure that I've explained it carefully. Then after that, I now came up with questions you should expect. I've studied the objectives that this topic should achieve. That is, what JAMB expects you to know under this topic. Do you see this trick now? If I tell you, this is what I expect you to know, what do I mean? I will ask you a question from that place. So, see, if you are a smart student, when I was in the university in those days, so many students come to me, they say, Mr. Emmanuel, please help us now. You, no matter how tough exams is, we will see you busy writing. We don't know. Do you used to see exam questions before exams? No. I was just smart. It's not even about reading several hours. It's about studying smart. See, I could guess the questions my lecturer could ask me. That's as simple as that. So, JAMB has already outlined the objectives under each topic. That is, they have outlined their major emphasis, what they actually want you to know. So watch this video till the end, because at the end, I have tried to put possible questions to, in fact, not possible questions to expect. So watch it from the beginning to the end. I put them at the end because I needed to explain first, so that I will now put those questions. And after you have watched this video, just like we did in the first topic in biology, I'm going to set several possible questions that may come out in physics in 2025 JAMB exams. And at the end, to my special students, please remind me. I will send this material to your group so that you can study it more later. So if you are in the special group, not those in common group, please. If you are in special group, please, anyone that comes across this should please remind me in the WhatsApp group so that I can drop this material at the end for your reference, so that you can study it again when you are less busy. All right, so let's go right into the topic. I don't want this video to be long at all. So please, I don't know. And someone complained the last time that I should be a little bit slower. I don't want too long videos. Let me see how I can be as much as fast yet clear as possible. All right, thank you so much once again for having you. If you are new here, so sorry, I may not be carrying you along in some things. Like maybe if I'm talking to my student, it may look as if, what's happening here? So sorry, I have a group of students I'm coaching, like I said earlier. We have a WhatsApp channel, special and common group. Is purely and completely free, but you must demonstrate a level of commitment. If you want to join, I will add you to my common group first, and then I will add you to my special group. If I see that you are dedicated and you are serious about learning, I'm not after crowd, please. I'm not after many people joining my coaching group. I have a target, I have a goal I want to achieve, and it's only serious students that I can work together with to achieve that goal. So if you feel you are one of them, you can be serious, reach out to me. I'll drop my phone number on the comment section. So chat me. I will find a way to add you. Thank you. All right. So the first topic under JAMB syllabus in physics this year is measurements and units. And this topic is so important. I have peeped into the syllabus. I have seen the objectives. So I have directed this class to those objectives to make sure that they have been achieved. All right. Look at this instrument. Are you familiar with it? Do you know what we call it? Do you know its name? All right, that's by the way. All right, we may, I don't know if time will permit us, be able to look at it. But then, um, this topic talks about measurements, and you are familiar with measurements, you are familiar with units. So this instrument, I will not say its name now. Some of you might have known it. Yes. All right. So, and I just decided to put it here. Let me advise you. Don't just know the name, know the parts. Yes. JAMB can be funny. I've seen questions like that where they will draw this equipment and they will say the part labeled 3 and 4 represents A. Anvil and spindle, B. Lock and thimble, C. Ratchet and sleeve, D. Anvil and lock. Do you understand what I'm trying to say? So if you don't know these parts, so that by the time you see this instrument and you see their label, Roman number 1, Roman number 2, for you to be able to, you will not get it. So this is one of the things I observed. They want you to know your measuring instruments and know their parts. And let me give you expo. You see this instrument, then you see vernier calipers. Yes, vernier calipers. Micrometer, screw gauge, and vernier calipers. Please, 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 and please know their parts. Know their parts. Very important. Please, let's go on. I don't want to dwell much on this. I hope my explanation is clear enough. Let's go. All right. So, I don't need to define measurement. It's a process of determining the size, length, and amount of something. It is essential in science and engineering for accuracy and precision. And we have 7 fundamental quantities. Now, when you are measuring something, you use quantities. There are units you use to measure something. For example, we measure weight in kilograms. We measure weight in kilogram. We measure distance in kilometers, meters, centimeters, and so on and so forth. So there is what we call fundamental quantities. Fundamental quantities are these quantities that are basic. They are basic. That is, they don't depend on another. By the time I continue, you understand. I will give more explanation on the next slide. Alright, so here are examples of basic quantities. Please know the difference between basic and derived quantities. Now, when we talk about basic, we talk about the last, the extreme last. What do we call primary school? Basic, right? Yes, we call it basic because that's the base, that's the beginning, that's the smallest. Do you get it? That's the lowest. So in basic quantities, these quantities are quantities that are basic. There is nothing they depend on. There is nothing they depend on. I will still make explanation on this to make sure you get it very well. So we have example of basic quantities. For example, length. SI means Standard International Units. I believe you have seen SI at the top. So SI means Standard International Units. Now, different countries have different units and they might adopt in measurement. But then there is what we call Standard International Units. Standard International Units are units that are used worldwide for quantities. For example, length. Length, the standard unit, Standard International Unit for measuring length is what? Is meter. Now, but do we only measure length in meters? Never. Do you get it? We measure length or distance in kilometers, in meters, in miles, in centimeters, in millimeters. in micrometers. Do you see? All these are units for length. Yes, for length. But then, which one is the standard international unit for measuring length? The one that is used worldwide, the one that is acceptable at international level, whether you are in America, you are in Europe, you are in Nigeria, Africa, you are in Asia, you are in Australia, or anywhere in the world. So the unit, the acceptable international unit for measuring length is what? Meter. Now, why is length basic quantity? Length is basic quantity because it does not depend on anything. For you to determine length, what do? You just put your tape, you put your ruler, depending on any measuring instrument you are using for measuring length. You just put it and take the length. That's all. Do you get what I'm trying to say? All right, I will show you derived quantities. You will understand better. Then the next thing is mass. Mass is also a basic unit, and mass is measured in kilograms. I hope you know there are other units for measuring mass. Please, don't be confused. These are the questions they will ask you. The SI unit for measuring mass is kilogram, milligrams, grams. Do you know that all these are units for measuring mass? But which one is the standard international unit? Kilogram, correct. Do you understand my point? So you have to know that there are other units for measuring mass, but the standard international unit for measuring mass is kilogram. You have to know this. All right, time. The standard international unit for measuring time is second. Temperature. You know there are other units also for time. We have minutes, we have hours, we have days, we have weeks. Do you get it? So all these are for time. Temperature. The units for measuring temperature. We have Kelvin, degree Celsius, degree Fahrenheit. All these are units for measuring temperature. But then you should know that the standard international unit for measuring temperature is Kelvin. Please note this, note this. There is difference between the unit for measuring temperature and the standard international unit for measuring temperature. I hope this is clear. Electric current is also ampere. All this, you just need a measuring instrument. You put your tape, you put your scale, you put your watch, you put your thermometer, you put your ammeter. Just, you take the reading. Do you get it? So these are basic quantities. Then we have luminous intensity. What is luminous intensity? Luminous intensity is the measure of the intensity of light. I don't want to use the word brightness, but that's a layman word to get it. The brightness of light varies. For example, sometimes if you switch on your bulb, depending on the voltage, if the voltage is low, not current, we are in physics. Some of you say low current, NEPA, low current. Which low current? That's not low current. Come on, you are smart, get it right. It's voltage. It's voltage, low voltage. So, where was I? All right, so we're talking about intensity of light. So sometimes if the voltage is low, the light will not be bright. So the intensity of the light will be low. But if the voltage is high, what happens to your bulb? Your bulb will shine brighter. So that means the intensity of the light is much. So there is a particular instrument used to measure light intensity. So, and the unit for measuring it, not just unit, the international acceptable unit, the standard international unit is candela. Candela. Then the amount of substance is measured in mole. Let's proceed, please. I don't want to take much time. Good, we are here. Now, if you didn't understand all the explanation under basic units, now listen to me carefully. You are going to get it. Remember, at the end of this, I'm going to show you possible questions to expect. Don't say possible questions, because I've studied the objectives. I've known what these people want you to know. So, and that's what they are going to test you on in your exams. All right, so when we talk about derived always has to do with something that is dependent, derived from, which means it was somewhere, but it was derived. It was removed from. So derived units or quantities are always dependent, and I will show you how they are dependent. So derived units are combination of base units. What are base units? That's basic quantities. So for you to have a derived quantity, you have to have a combination of one or two basic quantities. For example, now, velocity. Do you just measure velocity like that? No. Velocity depends on what? Length or distance, if you want to call it distance. And what again? And time. Do you get what I'm trying to say? So anytime you come to derived quantities, you would observe that it depends on a minimum of two. It can be more than two basic quantities. So velocity is meters per second. Do you see that it's depending on meter, which is length, and second? That's it. So this is what we call derived quantities. They depend on more than one. Unlike distance, you just put your meter rule, you put your tape, you put your vernier calipers, you put your micrometer screw gauge to get it. Do you get what I'm trying to say? So please, that is how you differentiate between derived units and fundamental units. What I used to know, and now I'm going to share one tip that I used to use very well to differentiate these two, is that if a quantity has a formula to calculate it, then definitely it is derived. But if I will just use an instrument and measure it, is basic. Do you get what I'm trying to say? So all the quantities that requires formula to calculate, they are derived units. They are derived quantities. So now understand derived quantities and derived unit. Unit has to do with what goes after your result. For example, 2 meters per second. That meters per second is the unit, right? Yes. So, but the quantity is the velocity. I hope you understand the difference between these two also. Unit has to do with what comes after, what describes the measurements. What describes the measurements? 10 kilogram. The unit there is kilogram. But what's the quantity? Mass. You are trying to measure mass. I hope this is clear. Alright, look at another. Force is also a derived quantity. The unit for measuring force is what? Kilogram meter per second square. Force is measured in Newton, but that Newton, the real meaning of that Newton is kilogram meters per second. Now, observe that right from this, what do we call it? Right from this formula or from the unit, it's obvious that force is a derived unit. It has more than one. It's not just in kilogram. Now, even though Newton is used as the unit for force, Newton does not just mean a single unit. Newton is from kilogram meters per second. Instead of saying kilogram meters per second, one word is just introduced. Newton. Okay, so let's go. Next is pressure, which is measured in Pascal. My student, what is another unit for measuring pressure? Hey, I have asked this, so I've explained this, so I think in chemistry class. Millimeter mercury, correct? Yes, when we're dealing with gas laws and so on. So, do you see another unit for measuring pressure here? I've stated it that day. And there are other units also for measuring pressure. These are not the only two. Please. We have ATM too, atmospheric pressure. is a unit for measuring pressure. So please don't think as if these things have only one, but they have international standard or acceptable units. So here we have Pascal. Pascal. So pressure, the unit for measuring pressure, the international accepted unit is Pascal. So, and that Pascal represents Newton per meter. Newton per meter. Now, if you are smart, you will know the formula for calculating pressure. Let me tell you, all the derived units, if you know their final units, all the derived quantities, if you know their final unit, you will know their formula. Yes. Look at velocity now. Velocity is what? Yes. Meters per second. So what should be the formula? Distance over time. Simple. Look at Newton now. Kilogram meter per second square. What is meter per second square? Acceleration. That's what we measure in meters per second square. So it means that the formula for force is mass times acceleration. Do you get it? Okay, we might have other formulas for the same force, depending on whether you are dealing with centripetal force, and so on. But then, from the units, you can know. Look at pressure now. Newton per meter square. Okay, can you tell us the formula from that unit? Yes, try. All right, Newton is force, don't forget. So force over area, meter square. So do you see that these things are just simple? See, if you are a smart student, you will not suffer. You study smart. Some students, I used to pity them. They want to cram all these things. For God's sake, do you have that time? You don't have that time. So you have to be smart in learning. Let's move on. All right, the next thing is conversion. Please expect question here. I'm already seeing it now. Expect question under conversion. Expect question. I'll teach you my trick for understanding conversion. All right, so look at the first one. 1 centimeter is equal to 0.01 meter. Assuming you are given 1 centimeter and are asked to convert it to meters or kilometers or miles, how do you go about it? All right, now always look at what you are given. For example, look at what we are given, 1 centimeter. Now that unit has already given you an expo on how you can answer it. What is centi? 100, correct. Please know these Greek words. All these centi, kilo, deci, milli, micro. See, if you know these small things, hey, you are 100 times greater than your fellows. And this is why I've decided to narrow this class to attend to my students. They have to get it. You just have to get it if you work with me. Sincerely, you just have to get it. I have a target with you. I want to be proud. I want to rejoice with you. By the time you finish writing your JAMB and you check your result, I want you to chat me. Hey, or you call me. Hey, Mr. Emmanuel, guess what? I have 330. Yes, I scored 332. I hope I will have people that will score more than that. It's possible. It's just about being smart. Make sure you set time aside each day for JAMB. 1 hour is not too small. If you can set 1 hour to study for your JAMB, I tell you, it will go a long way if you can be consistent. If you can be consistent. It is said that if you can study something for 1 hour, if you can learn something for 1 hour per day, by 3 months, that's 90 days, you have become an expert in that thing. Do you get what I'm trying to say? That 3 months is sufficient if you can dedicate 1 hour. Now, I tell you, if you can dedicate 1 hour each day for your preparation for JAMB, you cannot score a year mark. I tell you. All right, let's continue. So, look at 1 centi. Centi means 100. 1 centi. And centimeter is below meter. It's smaller than meter. So, since it is smaller than meter, you are going to divide. So, to remove the centi, remember we want to change it to meter. And to change it to meter, we want to remove centi and leave meter. So, and centi means 100. So, since centi is less than meter, we divide. I hope you get what I'm trying to say. Do you get it? All right. So, by the time I say 1 divided by 100, the answer will be 0.01 meter. Is this clear? All right. Assuming I have deci, deci means 10. Deci means 10. Milli means 1000. Micro means million. Nano means billion. Okay, forget about nano now. So just know centi, milli, micro, deci, and so on. So this is how you do your conversion easily. Now, from meter to centimeter, remember, from centimeter to meter, what did we do? We divide because centi is smaller than meter. So, now from meter to centi, we multiply. From bigger to smaller, we multiply. From smaller to bigger, we divide. I hope you get this secret. If I were you, I would write this thing and make sure I master it. Because that's the principle. That's the truth. Do you get my point? For example, 1000 meter to kilometer. Kilo means 1000. So now, from small, meter to kilo, meter is smaller than kilometer. Do you get it now? So, from smaller to bigger, I will divide. So, 1000 meters. Okay, let me say 2000 meters to kilometer. I now want to take it to kilo. So, I will divide by 1000. So, 2000 meter divided by 1000, because kilo means 1000. That will give me 2 kilometer. If you don't get it, just drop a question on that comment section. I will answer you. And if you are in my WhatsApp group, either special or common, just drop me a message on DM. I will explain. Some persons have been reaching out to me on DM to ask questions. All right. Hours to second. Let me not talk about that, please. Time is fast spent. All right. Significant figures, very important. You will be tested on significant figures. Yes. Even if the question does not come, let me tell you even how it comes. When a calculation is made, they can write the answers in different ways. Even the answers will be closely similar. They may be 0.001, 0.0001, 0.01001, stuff like that. So the answers will be very closely similar, but they are not the same. They will now say in two significant figures, decimal places, and so on. I just hope that you know this. I didn't really want to spend much time here, but just know these rules. And significant figure, this has to do with precision. I will explain the difference between precision and accuracy. Expect question from there. Yes, I will explain it later. So please note the rules. Non-zero digits are always significant. Any digit that is not zero is always significant. Zeros between non-zero digits are significant. if I have 0.101, the 0 is in between significant figures, so the 0 is counted as significant. Leading zeros are not significant. Zeros that come at the beginning are not significant. For example, 0.001, 0.001. The zeros that come before 1 are not significant. That's what we call the leading zeros. Then the trailing zeros are significant if after decimal points. Zeros that come at the end are what we call trailing zeros, and they are significant. So please note that. Let me go on. Measuring equipment. Please note measuring equipments and errors. There are errors that are encountered during measurement. You cannot measure accurately, exact. We only do approximations. We try to be as correct as possible, but it is very difficult in science to be 100% accurate. No. So vernier calipers has an error, a common error associated to it, and you need to know it. One of the errors is zero error and parallax error. Let me explain what this means. Zero error has to do with an error that is associated to zero. For example, let me use scale to make it very simple. If you remove anything on scale, this normal scale they use to measure meat and other stuff. If you remove meat sometimes, the pointer will either go after zero or before zero. It will not stop at exactly zero. That's what we call zero error. It can be positive, it can be negative. So it can be reading 0.001 just slightly after zero instead of reading zero. So that's what we call zero error. Then parallax error. Parallax error is as a result of your position in reading the measurement. For example, maybe I want to measure something using ruler. You now bend to look at it. That's parallax error. You cannot get it correctly. In our titration, there is what we call meniscus. Yes. When you fill your burette with acid, there is a layer. That's why you should stand perpendicular. That's the best position. You should always be perpendicular to what you are taking reading from. Don't be parallel to it. If you are parallel to it, you cannot get it right. So that's error. So error associated to vernier calipers is zero error and parallax error. Error associated with micrometer screw gauge is zero error. Measuring cylinder, which is used for measuring density and other stuffs, parallax error. Yes, because if you stand in a wrong location, you may not be able to see the layer where the liquid stops. Ruler is associated with parallax error if you didn't watch very well. So these are examples of errors. I don't want to dwell much on this, but it's self-explanatory, please. By the time I send this material to the group, you people will have access to it. I will send it to special group, please, not every group. All right, questions to expect as we round up. Which of the following is not a fundamental quantity? Questions like this can come up. Yes. So if you don't know your derived and fundamental, your derived and fundamental quantities, you are likely to miss it. Then they can show units. Which of the following units is for a fundamental quantity? Okay, let me ask that. Which of the following units is for fundamental or basic quantity? A. Newton. B. Pascal. C. Meter per second. D. Kilogram. What's the correct answer? Kilogram, of course. Remember, Newton is kilogram meter per second square. Even though they say Newton and it looks as if it is one single thing, you don't measure it to get it. Now, you see, I can list the quantities. I can decide to say, no, it's the units of the quantities. I will list. You try and identify which one is for fundamental or for derived. Oh, I don't know if someone is really getting me. This is how JAMB they can be. All right, thank you. Let's go. Next question. Why is the SI unit system preferred in scientific measurements? Okay, please, I want you to know why SI units is preferred. Please. I don't know. Question can come in any way. They can say SI units are preferred over other units in measurement because they are applied worldwide. They are used worldwide. Please. Give 3 examples of derived units and their derived quantities and their corresponding base units. Okay, I won't talk much about that. If you are asked to give the base units of force, I hope you can do that. Yes, kilogram, meters per second. That's the base unit, the end unit. Kilogram, you cannot go beyond kilogram now, can you? No. And this is what we call dimension. So you cannot go below. So if we say Newton, that's not a base unit because Newton means something. You can still go further. If we say Pascal, that's not the base unit. We know that is unit for measuring pressure, but that's not the base unit. The base unit is what? Yes, who can remember? What's the formula for pressure? Pascal. Yes, force over area. Now, if you still stop at force over area, remember, you still did not go to base units because force can further be taken to base units. So before you know it, you go to kilogram, meter per second square, all over area. That's the base unit. You have gone to the extreme end. They cannot go further, go down. All right. I've already spent much time, please. I need to end this video. So you should know conversion. Meters to kilometers, kilometers to meters. You should know parts of the measuring instrument. Please don't forget this. Don't forget this. Especially micrometer screw gauge. Go and browse it online. Picture or image of micrometer screw gauge and vernier calipers. See their labeling. I have seen questions like that several times that came up in JAMB where they are asking you the part labeled 2 is dash on vernier calipers or micrometer screw gauge. Please go and know it. Thank you for doing that. The day I will ask you a question on that, my student, don't think I'm joking. Because I just say, hey, Mr. Emmanuel say we should go and know it, and you forget it. All right. By the way, assignment is coming after this video, so I may decide to even ask you, even today. All right, so let's go. Parts of measuring instruments. Now, before I go about this, I saw a question. I think was it last year or 2 years ago, asking about error. They said the minimum allowable error in a measurement using meter rule is dash. So they gave several options. Error. So error, if you want to know the minimum error, you have to know the calibration. So the calibration will help you to know the error. For example, if a meter rule, the measurement on a meter rule, the calibration is from 0 centimeter to 1 centimeter, 1 centimeter to 2 centimeter, 2 centimeter to 3 centimeter, in that order, then the minimum allowable error will be 1 unit of that calibration divided by 2. That is to say, since it's from 0 to 1, 1 to 2, 2 to 3, what's the difference? The difference is 1 now. So you say 1 divided by 2, so which is equal to 0.5. 0.5. If it is in millimeter, do the same. So for any measuring instrument, this is how you find the minimum allowable error in measurement. I hope you get this. Thank you. Let's finish up, please. All right, accuracy and precision. Yeah, I said I will explain this previously. What is the difference between accuracy and precision? JAMB may ask, a student measuring the length, or let me say the breadth of his desk, found the following figures. Listen to the figures now. 2.01, 2.00, and 2.02. Now, what conclusion can be made from these readings? A, the readings are accurate. B, the readings are precise. C, there is no error in the readings. D, the readings are accurate but not precise. So which one is the correct answer? Now, accuracy has to do with how close your answer is to the exact value. Let's assume the engineer or the carpenter that made the tables used 2 meters, 2.00 meters. So that's the exact value now. But the student found 2.01, 2.00, and 2.03. Do you get my point? So these readings can be said to be precise. They are precise or precise. I don't know how you would like to call it. They are precise because they agree with each other. They are very close to each other, so they are precise. But accuracy has to do with how close the values you have found are to the exact value. Please know the difference. Accuracy has to do with assuming the carpenter used 1.5. So it means the readings are precise but not accurate. And now the carpenter used 1.5, but the student measured it 3 times in triplicates and found 2 point something. Do you see that? Whereas the readings among themselves agree, 2 point something. The decimal is just small. So the figures agree, but they are far from the correct answer because the correct answer is 1.5. So that's accuracy, how close your answer is to the exact value. Precision has to do with how close are the values you have found. How do they agree with the level of the agreement? All right, common errors. I've already stated that. Parallax, zero error. Please note those two for now. That's how they ask their question. How does parallax error occur? The direction you stand to take measurement. Please note that. They can say, how can you minimize parallax error? You see all these things. There are several questions that can be asked from this thing. How can you minimize it? By standing on a correct position, preferably perpendicular to what you are taking measurement of. So that's how to reduce it. I've stated parallax error again and again. Is the error that occurs due to taking a wrong position when reading your measurement. Tired. All right, let's finish up. Explain zero error in measuring instrument and how to correct it. So zero error, I've explained it. When the pointer is reading negative or positive to 0, that's zero error. How do you correct zero error? Okay, you calibrate. Sometimes if the instrument is bad, you just have to use another one. That's the best thing. So explain zero error and how to correct it. Forget that. Remember, your questions are coming in objective, but I told you how I brought these questions. They are objective. There is something JAMB wants you to know under this topic, and I made these questions or these statements out of it just to make sure that I hammer my explanation clearly for you to get it. Why is it important to consider measurement errors in scientific experiments? Why is it important? It is important because there are some areas that little error can cause destruction. I hope you know that. Let me give you an example. When we come to drugs, do you know that a little increase in concentration could lead to the death of a patient? Yes. If we come to engineering, a little mistake in mixing your cement in a normal ratio can lead to what do we call it now? Story building collapse. Do you see it? So we have to be very careful with errors and minimize them as much as possible. I thought I've come to the end now. Alright, so please, these are the instruments. Okay, I have this. So I'll drop this on the group for my students so that you can see them and study them more. Just know the parts. Alright, these are various measuring instruments. Thank you very much, everybody, for watching. If you are not my student, please reach out to me if you want to be. If you are my student already, expect assignment. Yeah. If you have watched this to this point and you did not like, am I doing well? Like now. Subscribe. Don't go without subscribing. Subscribe and hit the notification button so that anytime I upload, just be following me. Even if you did not join my WhatsApp group, just be following me bumper to bumper. I'm dropping highest 2 days. I don't almost every day say because my students, they have been waiting for me. Yesterday I did not post anything. They have been just chatting me on the group. So I know they have been expecting my assignment, all of them. So no problem. Please subscribe to this channel and be following me bumper to bumper. I tell you that you have no reason to fail JAMB this year. Not only are you going to pass, you'll pass well. That's just it. Because I'm doing a holistic training preparation for my students. Thank you very much and God bless.